Okay, so this is a test video to make sure that this is working. I'm going to solve this first up. So the first thing you need to do is expand the last two brackets. So x times x is x squared. If I go x times 2, that's plus 2x. If I go negative 1 times x, that's negative x. And if I go 1 times 2, it is negative 2. Okay, now I can simplify this because I've got 2x here and a negative x here, and that will do for this test. Okay, so this is the first revision sheet for Algebra Level 2, and you should be doing this if you are wanting to get achieved. So the first thing that we're going to do with this first one is I'm going to show you that we're going to expand these last two brackets. Okay, so I'm going to go to x times the x. I'm going to go then x times 2 and then a different colour. I'm going to go negative 1 times x and then negative 1 times 2. So the first bracket doesn't change, it's just 3x plus 1. And then the second bracket, I'm going to do those red lines now. So x times x is x squared. X times 2 is plus 2x. Note that it's a plus there and that's a positive x and a positive 2. Now I'm going to go 1. Now remember that 1 is a negative 1. It's a negative 1. Okay, it's got a negative in front of it. So it's going to be negative 1 times x. Negative 1 times x is it's going to be negative x. So negative x. And then negative 1 times positive 2 is negative 2. Now I can simplify that. I can go, so I'll leave that first bracket the same again, 3x plus 1, and then it's going to be x squared plus 2x minus x is just plus x, and then minus 2 at the outside. And the reason I can do that, just to be 100% clear, is that that plus 2x and that x are like terms. That is that they have a x and an x, they both have those, whereas the 2 over here doesn't have an x, and the x squared here doesn't have an x, it's got an x squared. Okay, so this is what I've got so far. Now I need to do exactly the same process as I did up here, but for these two brackets. So my first one, I'm going to go 3x times x squared, then 3x squared times x, then 3x times negative 2. And so I'll do that first. So 3x times x squared is 3x cubed, and then I'm going to go 3x times positive x, so that's positive 3x squared, and I'm going to go 3x times, and remember this is a negative, it's a negative, so I'm going to go 3x times negative 2, so it's going to be negative 6x, and I will not close the brackets yet because I'm not finished. Now the next step is I need to go everything 1 times x squared, 1 times x, 1 times negative 2, and in this case it is a positive 1, it's a positive 1. So positive 1 times x squared is, that's meant to be a, what's that meant to be? That was in, oh yes, it's meant to be an x, that is meant to be an x. Okay, so positive 1 times x squared is positive x squared. Positive 1 times x is plus x, and positive 1 times negative 2 is negative 2. Now, that's all the expanding done. All I need to do is figure out what the like terms are, just like I did up here. Okay, so I'm going to find, are there any other x cubes? No. Are there any other x squareds? Yes, there are. There's one over here, so I can go 3x squared, and then there's x squared there, so I can add those two together. Are there any other x's? Yes, there is. There's here, so I can add these things here together as well. And are there any other single numbers with no x's? No, there aren't. Okay, so now I just need to simplify that. So 3x cubed plus, now 3x squared plus x squared is going to be plus 4x squared. And then, now remember this is a negative negative 6x, and this is a positive x. So it's going to be negative 6x plus x, so that's negative 5x, and negative 2 is my final thing. And that is my first question done. On to question 2. So, my second question is asking me to factorise this, and I look at it and I know that it's going to be a hard factorising one because it has this 6 in front of it. So, the first step with these ones here is you need to multiply the 6 and the 12. So 6 times 12, and I can do it over on the side, 6 times 12 equals, now if you don't know that, you can go 5 times 12, and that's 60, and then you can add a 12 on, or you can just do it on your calculator. It's not hugely important. So the answer in this case is 72. So now I need to find two numbers. Use a different colour. So two numbers that multiply to 72 and are going to add to negative 1. Now I'm not 100% sure about that, so I'm going to have to think about it. So over here on my sort of working area, I'm going to go 1 times what gives me 72. Well, it's 1 times 72. 2 times what gives me 72, and I could do that in my calculator and I get 36. 3 times what gives me 72, and so I'm not 100% sure about that. It's 3's into 7 go twice, 1 left over, so it's 24. 4's into 72 once with 3 left over, so it's going to be 18. 5's don't go, 6's go, so 6 times 12, because we've already got that up here. And then I just keep going until these numbers here match. 7's don't go, 8's they do go. It's 8 times 9. And now if I went to the next number, it'll be 9, but I can see that I've already got a 9 here, so I don't need to go that far. Now, I'm going to look at all these pairs. Remember, I'm trying to find two of these numbers that multiply to 72 and add to negative 1. So, do 1 and 72, they all multiply to 72. Do they add to negative 1? No. Do they add to negative 1? No. Do they add to negative 1? No. 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 Yes. Look at this one here. See how they're only separated by 1? So I'm going to find a combination of these. That by combination I mean I need to find the symbol or the sign that will allow me to multiply to 72 and add to negative 1. So if it was, we'll just play around. If it was positive or negative 8 and positive 9, if I add those together, that equals positive 1. Is that negative 1? No, it's not. So the symbols must be the other way around. Okay? So they must be a negative 9 and a positive 8. And I'll just check that. If I add those, I'm going to get a negative 1. Okay? Now the only thing that I actually forgot to mention is that when I go 6 times 12, it should be a negative. It should be a negative 12 because of this negative here. That negative there. So it should be a negative 12 here. 6 times negative 12 is actually negative 72. Okay, so they should times the negative 72 and add to negative 1, and these two numbers, if I multiply those, I get that. If I add them, I get that. So that's great. Once I have these two numbers, I'm going to replace this x with x's of these coefficients. So the 6x squared stays exactly the same. Now I'm going to go minus 9x. It doesn't matter which order I do it in. And positive 8x. And the minus 12 will stay exactly the same. So all I've done is I've taken these two numbers here and put x's on them and put them in the middle. Okay. Now, once I've got to that stage, I need to factorise or find the common factor of those two, and then I need to factorise these two here as well. So I find what is common about these two numbers here, and maybe I will do this in red. What is common about these two things here? They both have x's, so I can put an x outside the front. And if I'm thinking of a number that goes into both 6 and 9, the answer in this case will be 3. So I can go 3x is common to those two things there, and so now I can put some brackets, and I'm asking myself, what times that 3x times what gives me 6x squared? 3x times what will give me 6? That'll be a 2, and then, but if I just go 2 times 3x, that would give me 6x, and I still need that squared, so there must be an x in there as well. 3x times 2x, yeah, that's 6x squared, good. 3x times what gives me negative 9x. In this case, I've got the x, so it doesn't need to have an x, but 3 times what gives me negative 9, gives me negative 9. It'll be probably, it'll be 3. So it'll be minus 3. Okay, that's the first part done. Now I go on to the bit in blue. So I'm factorising this. Again, I'm asking myself, what is a common factor? This one has an x, this one doesn't, so x doesn't go outside the bracket. They both have common denominator of 4 though, so I will go with that. We'll put a 4 outside the bracket. Note I haven't put a sign here yet. So 4 times what gives me 8x? 2x. And then 4 times what gives me negative 12? Negative 3 gives me that. This, and then, this is your test. Is that and that the same? Is this and this the same? Yes it is, then you've done it right. Okay, the only thing I need to do now is go back and put a plus in here. The only reason I didn't put that plus in straight away was because sometimes it could be a minus, depending on if this bracket is the same. If it's not the same, maybe putting a minus there might make it the same. So it's sometimes good to just go back and put it in later. But don't forget it. Really important to do. So now, last step. Last step is, just replacing that erase there, is to go, I'll use green for this, so this one here and this one here make up one of the brackets, 3x plus 4. And then this one here and this one here make up the other bracket. And because they're the same, it's just going to be one bracket, 2x minus 3. So see how that's a 2x minus 3, and this is a 2x minus 3. You just whatever is in this bracket, which is the same, goes there, and the other bracket is made up of whatever is outside the bracket and whatever is outside the bracket. And so that is that one there factorised. These ones here are probably the hardest achieved questions, I would say. Okay, except for potentially the next ones. So, next question, it comes to exponents. So we need to simplify this. The first thing we need to do is look, it has a negative 3. So if it's a negative 3, we're going to flip it upside down, and we can imagine that it is over an invisible 1. That's going to help us. Okay, so this will equal 1 over, and it's important that the whole thing is to the power of 3, so everything under here will be in brackets. 2x squared, and now I can change it to a positive. It's all over that. Positive 3, and so that's what allows me to do it. Changing that from a if I want to change that to a positive exponent, I need to flip it upside down. So that's what I've done. This will then equal, and I'm going to go. This becomes that there, the 2 to the 3. That will become 2 to the power of 3, and I'll go really slowly on this. So it'll still be 1 over. Now it'll become 2 to the power of 3. So 2 to the power of 3. And this x squared, this 2 and the 3 are going to multiply together. They're going to multiply together. So it's going to become x 6. Okay? And so that therefore will equal, just need to simplify that a little bit further, 1 will stay the same. 2 cubed, that equals 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, and then x 6. It's a 6 there. Okay? And that's your answer. That's all you need to do. Okay? Right. Next question. Just move down a little bit more. Right. This question here is a little bit tricky, but all you need to do is remember what roots and powers, how they change into fractions. Then it actually becomes not too bad. So, First thing you need to do is change them into exponents with fractions. So if I look at this one here, this 2 is going to go on the top, and that 3 is going to go on the bottom of my fraction. So that becomes x2 over 3. So it's an exponent. I'll just make sure that 3 is a little bit clearer. So it keeps popping up, which is awesome. Okay, I'm not going to do it because it doesn't like it. So x to the power of 2 over 3, that 2 came from here, and that 3, which has disappeared again, came from here. Okay, 3. The next thing is it's going to be still multiplied. It's a multiply sign, and again in this case it's going to be, that's going to be my bottom, my top, sorry, and that's going to be my bottom, just like the same. Okay, so the 7 is going to go, still going to be x. It's going to be 7 over 3. Okay, so now I can simply multiply these things, and when I multiply x's, I add the little add sign, I add the exponents, and thankfully I have a 3 here and a 3 here, so adding them is actually really easy. All you do is you add the tops, because the denominators, or the bottom numbers, are the same. So it just becomes x, and then it will become, if you really want, I'll make it nice and 2 plus 7 over 3. Okay, 2 plus 7 over 3, and 2 plus 7 is just 9 over 3. Final step, what is 9 divided by 3? Can I simplify that? Yes, I can. 9 divided by 3 is just 3. Okay, and that's all it is. The hard part on that is converting it from this to a fraction, I think, and then potentially if you've forgotten how to add fractions, that can be a little bit tricky as well. Simplify rational expressions. This one here will involve simple factorising to start with. So to factorise simply, as opposed to, when I say simple factorising, I'm talking about this up here. That's hard factorising because it's got a 6 in front of it. Simple factorising only has an x squared. It doesn't have a number in front of it. So when it is a simple factorise, I need to find two numbers that add to this and multiply to that. Okay, so I'm going to simplify, I'm going to factorise that top part for a start. So it's going to be, what are two numbers that add to -4 and times to 4? Let's go through the process again. 1 times what gives me 4 is 4. 2 times what gives me 4 is 2. And look at that, I've got to my numbers. Okay, I don't need to do any more. Now which one of these adds to -4? It's probably going to be this one here. There's 1 and 4, there's no combination of those that when I add them gives me 4. But I need to figure out the signs. The signs would be, if they're going to add to -4, they must both be -2's. So it'll be x, once I've got those two numbers, -2 and -2, I just put them in my bracket. So x minus 2 is my first one from my first -2, I'm putting that in there. And then my second one is I'm putting my second -2 in here. So x minus 2. All over, this will be x minus 2 still. Now, when I have, and this is what I was trying to get to, if I am multiplying here, if I'm multiplying, and only if I'm multiplying, I can cancel things. So I can cancel something that is similar on the bottom with similar on the top. For example, just to make sure that it's right, here there is an x, and I could say, oh, maybe I can cancel that x or that x, but I can't do that because it's not multiplying anything. It's being minused. Okay, it would have to be multiplying, and there would have to be a multiplying up x up here, and there's no multiplying x up here for me to be able to cancel. Okay, so x minus 2 and x minus 2, I can cancel that like that, and I can cancel that like that, and so I'm left with an x minus 2 on the top and a 1 on the bottom, and anything over 1 I can just write as the top. So x minus 2 is my answer. Okay, adding fractions. Let's do a cross and drop. So I'm going to do an arrow here, like this, and on every arrow I'm going to multiply. Here's my second one, and I'm going to multiply. Okay, so I'm adding. These are the harder of the fraction ones, I think. So my first one, x times 2x. equals 2x squared. And then x plus 2 times 3, all I'm going to do is I'm going to leave it expanded. So x plus 2. And I'm going to put that plus sign there. And then x times x squared, x plus 2, x on the bottom, so x times x plus 2, x times x plus 2, that's what I've written on the bottom. Now, it would be a good idea for me to expand those now that I've done it. Okay, so I've times along there and I've got 2x squared, I've times along there and I've got 3x plus 2, and I've times along the bottom and I've got this. And then I take my plus sign, if it was a minus sign I do the same thing, and I put it here. Okay, so 3 times x and 3 times 2, that will be 3x is the first one, that's 3 times x, and then 3 times 2 will be plus 6, okay, and then I've got this plus 2x squared, okay, and it's going to be all over x squared plus 2x. It's good to sort of look at this and think, could I do something similar that I did up here? Could I do something similar? Could I factorise the top into 2 brackets and maybe cancel? Generally for Achieve they won't ask you to do 2 skills, so it's unlikely, but if they did, I can kind of look at it and think, no, there's no way they're going to make me do that in Achieve. They might ask you to do it in Merit, but not in Achieve. Okay, right, dividing is the same as timesing, but one key difference, because it's a divide, I flip everything after the divide sign. Okay, so this is going to equal the first step. I'm going to flip that upside down, make it the reciprocal. That's the fancy word for it. Reciprocal is just it upside down or flipped. So I'll leave that the same. So that'll be 3x to the power of 4 y cubed all over 2, and I do my z's with a line through it so they look different. 2z2, okay, and now it's going to be a times sign multiplied by this upside down. So z4 over 12 x squared y. Now timesing is easier than adding. There is no cross and drop like you see up here. All you do is you multiply this by this, so you're going to multiply that by that, and you're going to multiply this by this. So let's do the big numbers first. By the big numbers I mean this here, and there is no number in front of it, but if there was we'd do that. So 3 times 1 effectively is 3, and then are there any x's here? Any x's in this one? No, so I can just leave that as an x4. And it's good to do this in alphabetical order. So y will come next. It'll be y cubed, and then it will be z4, and that will be all over. What is 2z? I'll do the x's first. So firstly I do my big numbers. In this case I can, so it's 2 times 12. 2 times 12 is 24. And then I'm going to go put my x's in. So it's x squared. I'll just make sure it's really clear. I'll put a 2 there. X squared. And then I'll put my y. And then I'll put my z squared. Okay. Now, I haven't finished yet. Now I can look for similar things in the top and in the bottom. And here, they are all multiplying together. They're all in these tiny little multiply signs. I can't really do them with this pen, but there's a multiply sign there, multiply sign there, and a multiply sign there. And so because they are multiplying, I can look at things on the bottom. If they're multiplying too, which they are, there's a multiply there, and a multiply there, and a multiply there. Because they're multiplying, I can cancel things out. Okay, let's do the letters first, because I think they're easier. So when I've got a Z4 up the top and a Z2 down the bottom, I minus the exponents. So it's essentially 4 minus 2. Okay, so that is going to equal, I'll leave room here for everything else I'm going to need to write, Z4, Z2. So 4 minus 2 will be Z2. Okay, because 4 minus 2 is 2. y3, and there is an invisible y1 there. It's invisible just because mathematicians are lazy. So we're going to go 3, and there's a 1, so it's going to be 3 minus 1. So 3 minus 1 will be a y squared. And then x4 and x2, again, it'll be 4 minus 2. So 4 minus 2 is x squared. Final thing, with the big numbers, I don't do this minusing stuff. All I do is I find a number that goes into both of them. And in this case, 3, there's the bell, I'm at school, 3 will go into 3, and 3 will go into 24. So 3's into 3 is 1, and 3's into 24 goes 8 times. However, in maths we don't need to write that 1, because we're lazy. So I can just get rid of that 1. And that there is your answer. X squared, y squared, z squared over 8. They're all multiplied together. Right. That is the question 11. It's time to do question 2. Now, I'm sorry that I've gone down. I figure that it's probably easier in terms of numbers. And because of that, I'll probably change the numbers so that it's easier for you to follow. Right. You can see up here that there isn't a link. There will be a link on your sheet, which is how you're watching this video. So, solve quadratic equations. I need to solve this. This is very similar to this question here with one extra step. Okay, to solve a quadratic equation, I need to factorize it. So that's going to get to 2 brackets equals 0. That's what I need to get it to. Okay, and so I'm going to do my best to get there. So, first step, we are going to, this is like a hard factorizing again. I need to multiply 5 and negative 2, and that is negative 10. Okay, I need to now figure out two numbers that add to negative 9 and times to negative 10. So we'll go through the process. So we'll go 1. 1 times what is 10, 10, 2. 2 times what is 10 is 5. 3 doesn't go in, 4 doesn't go in, and we're up to 5 again. Okay, so therefore those are the only numbers. Which of those pairs adds to 9? It's definitely that one there. How though? What symbol do we need to figure out that they add to negative 10 and times to add to negative 9 and times to negative 10? So in this case it will be if it was a positive negative 1 and a positive 10 and I added those, I'd get positive 9. So that's not right. So therefore it's going to have to be the other way round. Negative 10 and positive 1. They do add to negative 9. Therefore I can replace the 5x squared stays the same. I can replace this negative 9x with these two numbers with x's on them. So I'll put the negative 10 first. Doesn't matter. 10x plus 1x minus 2 equals 0. 5x squared minus 10x plus 1x. Now I'm going to factorise these two, and I'm going to factorise these two. And I'm just going to leave that minus 0 the same at the moment. So what is common about these? Both of them have a 5 in it, so I can put a 5 there. They both also have an x, so I can put an x there. 5x times what gives me 5x squared? It's x. 5x times what gives me negative 10x is negative 2. Now I need to factorise these two. What is common about these? In fact, it's just there's no number and there's nothing. So therefore I can put a positive 1 on there. Sorry about that. Someone came in to my class. So we're up to this step here. 5 times x gives me, and then 5 times x gives me negative 10x. So now I'm finding a common factor of these two here, and in that case it will be negative. It'll just be positive 1 because there's no number. And so I'm going to go 1 times what gives me 1x. It'll be x. 1 times what gives me negative 2. It's negative 2. and it still equals 0. Okay, test, do these things here look the same? Yes, they do. I've done it right. So last step is to put the things in the brackets. So 5x plus 1 is 5x plus 1, and x minus 2, x minus 2. So how I did that, to make sure 5x plus 1 goes there, and we'll use blue, we'll use grey, we're already under grey. So x minus 2 and x minus 2, that goes there, and it's still equal to 0. Notice how I've gone 0, 0, 0, all the way down, okay? Finally, I can do the solving part. All I've done is factorising so far. Solving a quadratic equation, what I need to figure out is I need to figure out, well, if these two things here are separated by a multiply sign, that is essentially saying something times something equals 0. And if I write that over here, we'll make one of those somethings x, and there's a times sign, and the other is something a y, and it equals 0. For two things to multiply to equal 0, there must be, one of these must be 0. They could both be 0, because if it was 0 times 0, you get 0. But one of them must be. If y was 5, for example, and x would have to be 0 for you to go 0 minus times 5 equals 0. One of them must be 0. So what I can do is I can say, well, if both of these things here times together to equal 0, I could say, therefore, that either 5x plus 1 equals 0, or x minus 2 equals 0. And this is exactly how you solve it, okay? So I'll do the easier one first. If x minus 2 equals 0, what minus 2 gives me 0? Well, 2 minus 2 equals 0. So x would equal 2. Or, if it's this one, I can go 5x plus 1 equals 0. Well, I've already done that. 5x plus 1 equals 0. What I'll do is I'll take the 1 and put it on the other side. And to do that, I'm minus 1. I'm minus 1 because it's adding here. And I do the opposite of that. So it's 5x equals negative 1. Negative 1. Now I need to get rid of that 5, so I'm getting down to x equals. And to do that, I need to divide by 5. I need to divide that by 5, because whatever I do to one side, I need to do to the other. So I've got x equals negative 1 over 5. It's just negative 1 over 5. They cancel out. That's why I'm left with x. Negative 1 over 5. And you don't need to change that to a decimal. That'll do. Okay? So in this one, if I wanted to write it over here, I would say x equals 2 or negative 1 over 5. And I put a little box around it. Make sure the marker knows exactly what I'm doing. Okay? And that's what you're always going to get with solving the quadratic equations, because of this 2 here. You will always get two answers. You'll always get two answers. So it's factorising all the way to there, and then there's just this little bit extra to solve it. Okay, that's solving quadratic equations. Next question, solving these. Now, hopefully you see this and you're like, okay, I know how to do this. It's logs. Okay, if there's an x up here, I need to log it to be able to figure it out. So I'm going to go, I'm going to log both sides. Log 6x 6 equals log 1296. So I've logged both sides. Now I can bring that x and put it down here. Put it down in front. So I'm going to do that now. X log 6 equals log 1296. And now I want to get to x equals something. So there's an invisible times sign here. So to get rid of that log 6, I need to divide that by log 6 and that by log 6. So I'll do that now. Dividing that by log 6 and dividing that by log 6. These things here will cancel out, thank goodness. And I'm left with x equals. Now I will do this, you need to do it on your calculator. So I'll get my calculator and I turn it on, I find the log button, press the log button and go log 1296, and then it's really key that you press the divide sign. You don't press the A, B over C sign, okay? You press this sign. So you've gone log 1296 divided by log, button again, and then 6. And that gives you an answer which equals 4. So x equals 4. Nice and easy. Nice and easy. Solve equations and inequations. So this one here, solving an equation, is actually relatively similar to this last part of solving quadratic equations. Quadratic equations are these ones with x squareds. Very similar to this part. So this part here is factorising, and this part here is actually very similar to solving linear equations. And linear just means x. There's no x squared, just x. So with these ones, what I need to do is, and this is an equation has an equal sign. An inequation is exactly the same, except it has this greater than or equal sign. Okay, and we'll get to that greater to or less than sign, and we'll get to that in a second. So to be able to solve these, my goal is to get all x's on one side. All x's on one side. So here I see I have an x on this side of the equation, and I have x's on this side of the equation. So that's not useful. I need to get all my x's on one side, and it doesn't matter which one, but I need them all to be on one. So I'm going to leave the 5, so it's not doing anything to my x. I'm going to expand these brackets first, okay? Because I can't move the x at the moment, and so I need to expand it to be able to move the x. So I'm going to go 3 times negative 3. So negative 3. Negative 3 times x is negative 3x. Negative 3 times, note this, it's a negative 2. Negative 3 times negative 2 is positive 6 equals x, because nothing's happened on that side. Now I need to remember I need to get all my x's on one side, so I can move this x over here, or I can move all my x's over here, but I'm going to do it this way. All my x's on this side. So what is this x? How do I get rid of that negative 3x? Well, currently it's kind of a minus 3x, so it's minusing this side. So the way I get rid of it is I add 3x to this side, and I add 3x to this side. So that will cancel out, negative 3x, positive 3x, 0. And then I've got a 5 plus 6 left, and x plus 3x is 4x. Now I can do a little bit more simplifying, because 5 plus 6 is 11. Equals 4x, and I'm almost there. So that once I've got all my x's on one side, now I need to get to x equals. So that's kind of step 1, and this is step 2, is to get to x equals. So at the moment I've got 4x equals. I want to get to x equals, which means I need to get rid of that 4. To do that, I ask myself, what is the 4 doing to the x? It is multiplying. And so to get rid of it, I divide by 4. So I divide that by 4. And so therefore, the 4's will cancel out, and I'm left with x equals 11 over 4. And it's okay to just leave it as a fraction. You don't need to change it to a decimal. You don't need to change it to an improper fraction. If you did, that would be okay, but it's easy to mark if you leave it like that. Markers like you if you leave it. And then I'll put a box around it. That's my answer. And note, just on that note, if I look at this, and I've got lots of working all over the place, note how I've got this beautiful little answer here in this box. That's a really good habit to get into, because then markers will know, oh, there's the answer. Great. Okay, next one. This is exactly the same, except this sign changes things ever so slightly. But pretend that is an equal sign. So I'm going to get all my x's on one side, so I'm going to expand first. 2 times 3x is 6x, and then 2 times negative 1 is negative 2, and I'm going to put that sign in, that's a greater than or less than sign, and then the 1 minus 2x. Have to get all my x's on one side, so I need to get rid of this positive 6x. To do that, I'm going to minus 6x. I'm going to minus 6x from this side. I can equally put the 2x over here by adding 2x, but I'm going to put the 6x over here. So negative 6x, those things there will cancel out, and I'm left with minus 2. 1 minus 6x minus 2x minus 6x is minus 8x. Need to get that 1 now over here. So I've just got x's on one side. It's a positive 1, so to get rid of it I need to minus 1. Negative 1 minus 2 is negative 3. 1 minus 1, they will cancel out, and I'm left with negative 8x. That's great. Now, how do I get rid of that negative 8? Because I just want to get to x equals, just x equals, although in this case it would be x. I want to get to this, x something like that. To get rid of that, I divide by negative 8. Divide by negative 8. Exactly the same so far. And this is where it changes. The only thing extra about inequations is this thing here. If you ever divide or multiply by a negative number, then this changes direction. So here, see, I'm dividing by a negative 8 because I'm trying to get rid of that negative 8. If I just divided by 8, this wouldn't change, but because it's a negative 8, or if it was a negative 2 or anything, this just needs to change direction. So I know in my next answer, I'm going to have that instead of this. And then I'm going to go negative 8 over negative 3, or negative 3 over negative 8 I should say, and this can be, they will cancel out, and so I'm left with x. That's the only difference. And then because these both have negatives, from being correct, I will just get rid of those negatives and make it a positive. But if you left it as a negative, it wouldn't be the end of the world. So the only difference between this one here and these ones here are that if you divide by a negative, this changes direction. That's it. The only difference. Right. We are almost there. Almost there. Solving logs. This one here, I need to, the x will stay where it is. Remember, that's that formula. The 5 goes up to here, and then the 2 goes up as well. So it becomes x equals 5 to the power of 2. And then I can just say, what is 5 to the power of 2? That is 25. That's it. X equals 25. Only hard thing about that is you need to remember how to rearrange that into that. It's the only thing. Only thing. And you can always pick it because there'll be a different base, not a log base 10. Not a log base 10. Okay, I'm still solving. Solving generally means you need to use a calculator. So I could have gone 5 squared on my calculator. In this case here, I'm going to have to use my calculator. So I need to get to x equals something. And so what I'm going to do is I've got log x equals 3 log 2. Remember, in any sort of equation, I'm just trying to get to x equals. So I need to get rid of that log. Unfortunately, this is not timesing. This is logging. So to get rid of it, I need to actually take the exponent of both of these things, or the exponential of both of these things. In other words, you don't need to know what that means. All you need to know is that if I get rid of a log here, I need to get rid of a log here. And the only way I can get rid of a log here is by putting that 3 up here first. Okay, so my first step will be x equals, log x equals log 2 to the power of 3. So with logs I can put that here. Okay, so log 2 to the power of 3. Now I can get rid of my logs, as long as I do it on both sides. Just like I can log both sides, I can take a log away from both sides. So I'm left now with x equals 2 to the power of 3, which is not too bad. 2 to the power of 3 is 2 times 2 times 2, which equals 8. So x equals 8. That's the answer. Okay. These log ones are kind of very easy in terms of working, but they can be slightly complicated because you've never seen them before. Okay, this one here is to write as the log of a single number. I am not using my calculator for this. I'm not solving. So log 3 plus 3 log 2. I need to firstly put that 3 up here. So it becomes log 3 plus log 2, 3. Now I can do that. So log 3 will stay the same, log 3. 2 plus 2 to the power of 3 we actually just did up here. 2 to the power of 3 is 8. Log 8. Now, when you add logs, you multiply these numbers. When you add logs, you can multiply these numbers. So it becomes log of 3 times 8 is 24. Okay, and then I'll just write log 24. And I'll just go back one step and just write that out properly, just to make sure. So 3 times 8. In there I would write 3 times 8. 3 times 8 because I'm adding logs. And that, as I say, is that. Okay?